For years, we pictured Neanderthal women as passive survivors. Then genetics upended everything. Today, not a single Neanderthal Y chromosome remains in any living human, but their female lineage endures within our DNA. Why did the daughters survive while the fathers vanished? The answers force us to rethink who truly shaped the future of our species. Roughly 50,000 years ago, two human groups met in Eurasia: Neanderthals with their deep roots in Europe and Western Asia, and Homo sapiens newly arrived from Africa. When geneticists mapped the DNA of people living today, they uncovered a surprising inheritance. About 1 to 2% of the genome in non-African populations comes from Neanderthals. Yet a closer look at the genetic record revealed a striking absence. Not a single Neanderthal Y chromosome survives in any man alive. The Y, passed only from father to son, vanished completely. At the same time, Neanderthal mitochondrial DNA, inherited through the maternal line, also disappeared. What remains is a filtered legacy, preserved only in the parts of the genome that recombine and persist through both sexes. The story of how these genes entered our lineage centers on a window of time between 50,500 and 43,500 years ago. During these 7,000 years, Neanderthals and modern humans interbred. Most of the Neanderthal DNA found in living people traces back to this single shared period of mixing. But not all genes survived the passage of generations. Some regions of the human genome, especially those linked to fertility and the X chromosome, show large stretches where Neanderthal ancestry is almost entirely missing. Scientists believe that many Neanderthal variants in these regions were quickly purged by natural selection, likely because they reduced the fitness of hybrid offspring, particularly males. This pattern has led researchers to ask whether certain types of interbreeding, perhaps involving Neanderthal women and Homo sapiens men, were more successful over time. The evidence remains under debate. What is clear is that only a small subset of Neanderthal lineages, filtered by biology and chance, became part of the modern human story. As one lead geneticist put it, "Our DNA remembers the Neanderthal encounter, but only fragments remain, enough to remind us how close their world came to touching ours." Neanderthal women carried a kind of power that defies modern comparison. Their bones, especially the upper limbs, tell the story. Osteologists who study humerus cross-sections have found a level of strength that rivals and sometimes surpasses today's elite female rowers and professional athletes. The geometry of these ancient bones reveals thick walls and wide shafts, adaptations built up by a lifetime of heavy, repetitive work. Muscle attachment points where the deltoid and pectoral muscles once anchored are pronounced and rugged, far more so than in most modern skeletons. This is not just a matter of genetics. It reflects daily demands that push their bodies to the limit. CT scans and biomechanical models show that Neanderthal women's arms endured forces well beyond what most people encounter today. Researchers measure the polar second moment of area, a technical term for how bone resists bending and twisting, and find values that match or exceed those of athletes who spend years training for world-class competition. But Neanderthal women developed this strength not for sport, but for survival. They likely hauled carcasses, scraped hides, and shaped stone with the same arms that defended against predators and braced against the cold. These anatomical signatures are not isolated. They appear across multiple sites and individuals, painting a picture of women who were not only capable, but essential to the physical demands of their world. Their bodies were built not for comfort, but for endurance, resilience, and the relentless work of staying alive in Ice Age Europe. Archaeologists working in the caves of northern Spain have pieced together a record of Neanderthal life that upends old assumptions. Among the scattered bones and tools, They found skeletons of both men and women, bearing the same kinds of injuries. Healed rib fractures, broken arms, and trauma to the skull appear across sexes, not just in the remains of adult males. Some of the most telling evidence comes from rib bones, cracked and then knit back together, injuries that match those seen in people today who work with large animals or take part in high-risk physical labor. These patterns are not random. They mirror the wounds found on modern big game hunters, especially those who face dangerous prey at close quarters. In several Spanish sites, the faunal remains tell a similar story. Large mammals like bison, red deer, and horse dominated the kill assemblages, and the cut marks on bones suggest coordinated group hunts. The fact that Neanderthal women show the same trauma as men points to a shared role in these perilous pursuits. Field osteologists examining these bones in situ have described the distribution of injuries as evidence that hunting was not a gendered activity. The days of picturing Neanderthal women as passive gatherers stand in sharp contrast to the reality written in their skeletons. Instead, the archaeological record reveals women who faced the same risks, bore the same scars, and stood shoulder to shoulder with men in the hunt. For centuries, the image of a Neanderthal woman was little more than a shadow, heavy-browed, stooped, almost cartoonish. That picture has been quietly erased by a new generation of forensic artists and scientists. Using computed tomography scans of real Neanderthal skulls, specialists map every contour and crevice, building up layers of muscle and flesh with the tissue depth method. Each stage relies on precise measurements, not guesswork. Where bone is missing, mirrored anatomy and comparative data fill the gaps, always anchored to what the fossil actually preserves. As the face takes shape, something remarkable happens. The eyes are large, set beneath strong brows, yet unmistakably human. The nose is broad, the jaw robust, but the skin, guided by ancient DNA, may have been pale, even freckled. Some Neanderthals carried gene variants linked to red hair and light skin in modern people. So artists sometimes choose a coppery hue, a hint of individuality lost for millennia. The Dutch team who reconstructed Kreen, a Neanderthal from the North Sea, achieved a face that feels familiar, alert, thoughtful, alive, while Kreen himself was male. Similar techniques applied to female skulls reveal the same blend of strength and humanity. These reconstructions sweep away the old caricatures. They invite us to look past the stereotype and recognize kinship, faces shaped by struggle, endurance, and the same spark of life that animates us today. The arrival of a Neanderthal child was never guaranteed. Anatomists studying fossilized pelvises and newborn skulls have reconstructed a birth process fraught with danger. Unlike the relatively round birth canal of modern humans, the Neanderthal pelvis was wider from side to side, but the infant head itself was also large, almost matching the size of a modern newborn brain. Computer models suggest that Neanderthal babies needed to rotate during birth, twisting through a narrow passage with little margin for error. Even a small misalignment could threaten both mother and child. In a world where every life counted, these risks carried weight. A difficult birth could mean the loss of a mother, an infant, or both. That loss rippled through small, tightly knit groups. Paleo-obstetric specialists point to this mechanical challenge as one factor that may have limited Neanderthal population growth. In an environment where survival was already uncertain, the hazards of childbirth added another layer of fragility to their story. In a Croatian rock shelter, archaeologists uncovered eagle talons with deep, precise cut marks, clear traces of deliberate shaping and polishing. These talons, dated to nearly 130,000 years ago, were not tools or food scraps. Microscopic analysis shows wear patterns from suspension, suggesting they were strung and worn, perhaps as pendants. Such objects reveal a mind attuned to meaning and status, qualities once thought unique to our species. In Spanish caves, faint red discs and ladder-like signs linger on limestone walls. Recent uranium-thorium dating pushes some of these paintings back more than 64,000 years, predating the arrival of Homo sapiens in the region. Not all experts agree these marks are Neanderthal-made, but the possibility has opened a new debate about symbolic expression. Meanwhile, geneticists have traced certain immune alleles in modern Europeans and Asians directly to Neanderthal ancestry. These genes help fight infections even today, a biological echo of ancient survival. Objects, pigments, and DNA together form a legacy that endures, not just in artifacts or bones, but in the bodies and minds of their distant descendants. Every time you look in the mirror, fragments of Neanderthal legacy stare back, proof that ancient encounters still shape our lives. As new discoveries rewrite human origins, the story is not finished. Our shared past is written in our genes, and its next chapter is being uncovered right now.